Multiplying and dividing radicals, algebra 2, trigonometry regions. So the previous video was adding and subtracting radicals, and I mentioned how you needed to have a like radical in order to add them. Like if you had rad 5 plus rad 2, that does not equal rad 7. You can't add these together. However, you can multiply them. You can do rad 5 times rad 2 to get rad 10. So and it's the same thing with fractions and exponents and variables and all sorts of things that addition and subtraction, you got to have like terms, but multiplication and division, you do not. So this fraction here, remember fractions are really a form of division. I would read this as 14 rad 50 over negative 7 rad 2 is saying 14 rad 50 divided by negative 7 rad 2. And even though these are definitely different rad terms, rad 15, rad 2, like I would not be able to add them, I can definitely divide them. I can multiply them. So I can divide, and basically you divide coefficients on the outside, and you divide radical numbers on the inside. So this would divide to negative 2 rad 25. Because 14 divided by negative 7 is negative 2, and 50 divided by 2 is 25. And then I would reduce from there, and in this case, the square root of 25 is a square, it's 5, and so negative 2 times 5, my final answer, is negative 10. This time we're multiplying. Rad 3a times rad 15a squared, and so I can multiply the terms inside. So 3 times 15 is 45. And a to the first times a to the second is a to the third. When you multiply variables that have a common base, you add their exponents. And we're going to have a whole chapter on exponents, but you are expected to know the basic kind of stuff like this, that, you know, a to the first times a to the second is a to the third. And just a really quick background on that, like say you had x to the fourth times x squared, that would be x to the sixth, because remember, x to the fourth means x times x times x times x, and x squared means times x times x. So it's a total of x times x times x times x, you know, 6x is being multiplied. So that's why we add our exponents when you're multiplying a common variable base. So 3 times 5 was our 45, and a to the first times a to the second was a to the third. Simplifying 45, I can use 9 times 5, where this is my squared, so that's going to be the 3 with a rad 5 left inside. And as far as the a's, remember what we do here. Now this is square root, so I'm going to divide 3 divided by 2. 3 divided by 2 is 1 with a remainder of 1. And that is it for that one. One more. This will be a short video today. So these are radical terms. 8 plus rad 3 times 2 minus rad 3. Like this is not the same thing as 8 rad 3, but 8 plus rad 3. It's almost like 8 plus x kind of thing. And you could probably guess here what we're going to do. We're going to distribute. We're going to, you know, FOIL. We don't really call it FOIL anymore, but I know you guys grew up with FOIL, so I'll call it FOIL for this video. But it's basically distribution. I'm going to multiply everything over here by everything over here. And so what happens? 8 times 2 is 16. 8 times negative rad 3. Now, 8 is a regular number. It's called a constant. Negative rad 3 is a radical number. It's still a constant, but it's not the same thing. So I cannot multiply them together in the same sense that I can like rad 5 times rad 2 is rad 10. So what happens when you have like a number times a radical, they just kind of get put together. Like when you do 2 times x, you get 2x. Well, when you do 2 times rad 5, you get 2 rad 5. You know, it's the same type of deal there. So 8 times negative 1 rad 3, if that helps, is negative 8 radical 3. Radical 3 times 2 would be positive 2 radical 3, because remember, again, this is not a radical, but this is. They're both positive terms, that's why it's positive. And then the last one is probably the most significant. Positive rad 3 times negative rad 3 is going to be negative, because a positive times a negative is negative. But radical 3 times radical 3 is 3. And we saw that at one point when we had a radical squared, because square and square root kind of cancel each other out. I think the analogy I used in class was opposite sides of the same road kind of thing. It's almost like plus 2 minus 2. So rad 3 times rad 3 is 3. You could think of it in multiple stages. Add rad 3 times rad 3 is rad 9, and rad 9 is 3. But however you come to grip with it, rad 3 times rad 3 is 3. And then at this stage, you just look for any like terms. So 16 minus 3 is 13, and negative 8 rad 3 and positive 2 rad 3, these are also like terms because they have the like radical of rad 3. That's going to be minus 6 rad 3. So 13 minus 6 radical 3. And I think this is probably a record, under 6-minute video. See you later.